Hello. Welcome to Unit 5, Arrays. In this unit, we are going to cover the following. The concept of array and how do we declare arrays, the concept of how do we use the array constants, or how do we specify constants for an array, and the initialization of arrays. How do we provide values to our array that has been declared? How do we get values using the input statement for the arrays, and how do we display the same using output statement for arrays, and how do we use the arrays in expressions, the concept or the difference between whole arrays and the array subsets, and some operations that are available for whole arrays. We'll finish by looking at the allocatable arrays. So we begin our journey. The array arrays, or just array, is a method of storing many values. This is one of the keywords. It's a method of storing many values of the same data type. This is also another keyword, of the same data type under the same variable name. This is another thing. So there are three important things that we need to be considering in our array. Our array is a method, or is a structure in a programming language that is used to store many values, and these many values should be of the same data type, and of course all those values, or many values that we have, will be known under the same variable name. So for a programmer, is going to just know one variable name, but that variable name will be pointing to many values of the same type. To this far, we've been able to declare variables, but we are declaring one variable for one value. Maybe a variable to keep age, or a variable to store temperatures. It was only one variable. We would declare maybe a variable of data type integer. It would be storing only one variable at a time. But now we are saying we can actually process some data as a group together, instead of considering them as a single item. So we can have them as a group. For example, we may want to process the maybe average for the class, average for the scores of Fortran for all students that we have. So all these grades or scores that we have are of the same data type. They are numbers, for example, maybe real, maybe integer, and they will be treated as one thing, instead of declaring maybe different variables for each and every student score. We can just have one variable name that is pointing to so many values, to so many scores, and we can use that structure to, for example, calculate average, or maybe calculate the range, or whatever we want, maybe to identify the highest score and the lowest score. So we are dealing with that data as just one data set, but this data set is of the same type. Yeah. So it can also be described as a data structure in which data of the same type can be stored, and of course it provides a way of retrieving each data type, or data item, in any order. So if we have 10 numbers that have been declared as an array, you can start displaying any number that you want. You can start a number which is on position 10 without necessarily going through those numbers which are position 1, 2, 3, 4 up to 9. You can go straight to position 10. You can display a number which is on position 5 or on position 6. It's up to you. So it provides that way of retrieving your data in any order. Array values are stored in what we call contiguous memory address in the computer. So when you have declared a variable, from what we've done so far, if you declare two variables and you have maybe this as your memory, and this memory has got different addresses, or what we can call small compartments that are used to store data. And if you have declared two variables, maybe variable A and variable B, what will happen is, if you have declared them as integer, maybe variable A would come and sit here, maybe with a value of 20. So it would be here. This would be variable A. And we will have another variable B declared. Maybe instead of declaring or maybe creating a memory here, the B would be stored somewhere here. And maybe it would store, okay, let's just say it will store 4. So this would be variable B. So this is what happens. So when you are declaring variables, you don't have a control where that variable is going to be stored in the memory. The two variables that you have declared may be allocated in addresses next to each other, or they can be addresses which are far apart. So knowing the address of one variable may not help you identify address of the next variable. But with arrays, what we are saying is the arrangement is different, as we're going to see using maybe a graphical representation, that the variables are stored actually in a contiguous manner, in a contiguous memory address. So if you have declared a variable of 10 integers, it means all those 10 integers will be next to each other. The first value will be here, another one here, so they will be next to each other. This helps us that if we identify or we access the first variable, or the first value, it can help, or we can easily go to the next value, because we'll just be moving one step ahead and it will be giving us another value, because the first and second values are next to each other. So that's how values are stored in a memory. So we are able to move. If you just have one jump, you go to the next element or next value. Another jump, you go to another value, up until you reach the end of the structure or our array. Okay, so that's a concept of array. Graphically, we can present it this way. We are making an assumption that we have a big container. That's what we can call array. So this is our big container, and this big container will be having other containers. If we are declaring 10 numbers, it means we are going to have those 10 numbers or 10 integers or real inside this big container. So all the 10 numbers that will be inside here, all the small containers that are put inside, will be known by the name of the big container. And the big container, the name of the big container just helps us to identify the first element. And from there, you can access any element by just jumping by one. Or sometimes we use the name of the big container and of course, the position of the small container we want it to open or use. So you can use the name of the big container, in this case is a container A. And if you want to get this, then we are going to say container A on position 3 is going to give us this container, the value for this one. But this is a graphical representation of that. More on graphical representation of an array, assuming we have an array of n numbers. So as we said, they are stored contiguously. So we are making just an assumption that the first address is 1000, then the second address is 1001, 102. This is a simplified and maybe representation of the addresses. Actual addresses would not be as shown here, but we just want you to get the concept. So the next one, 103, all the way up to where n is. We've just shown first 6 addresses. Okay, so on each slot of the memory, there is a value that we have. For the arrays of n numbers, we have first value as 234, another one 18, another one. So they're just next to each other. Another one 19, another one blah, 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 blah. And these elements have got positions, and we call the positions as the indices. So we have index 1, index 2, index 3. Sometimes the index is called the subscript. So it's like we have subscript 1, which is pointing to this small container. Subscript 2 is pointing to this other container, which is the location for the other container, all the way. So if we want to access, for example, 19 here, then we need to know the name of the array and the position of 19, which is the index 4. So we use both the name and the position to access 19. Okay, so that's what we can have, and this is very important for us to easily understand arrays and manipulate arrays. We need to understand that arrays have got that contiguous memory allocation as their storage, and we can access elements using the name of the array plus the position, which we call indices. So array has got a name, and the item of an array is called an element. So we can have maybe 10 integers, then we say our array has got 10 elements. And the index is what represents a position of an element, and is also called a subscript, as I said. The total number of elements, if your array is storing 10 elements, that 10 is called a size, or what we call array size. In Fortran, the default indexes, the default value for indices is actually 1, and it ends at the size. So if you have 10 numbers as arrays, you have declared them as arrays, then the positions to access their elements would be 1, 2, 3 up to 10. So of course, you can sometimes modify the default starting point and ending point, as maybe we are going to see later. And the arrays can be of 1 dimension or 2 dimension, which we call the ranks. So the demonstration we are going to have in this is going to be 1-dimensional array. But sometimes we can have an array that should store a structure such as a table. A table has got rows and columns, and to store such a thing we need a 2-dimensional array. But in most cases we'll be using, in this semester, we'll be using a 1-dimensional array, although you are encouraged to explore 2-dimensional arrays as well. But with a 1-dimensional array, it's like we have a vector. So we'll be dealing with vectors, while the 2-dimensional arrays, it's like you are dealing with the matrices. Okay? So how do we declare a variable, arrays? We declare arrays by using a dimension attribute. For us to declare a normal variable, we would just have integer, maybe these symbols, then grade, something like that. But here now we are putting in something in between, which is the dimension. So integer dimension 5. That's how you declare arrays. So grades here, it means is going to create a space which is enough to keep 5 elements of data type integer. If you want to keep for the strings, then we are saying character. Each character, you specify the length of the character, and you want to keep 5 names, but each name should be less than or equal to 20 characters. So you want to keep 5 names, then you can declare using this. The number of elements in a given dimension of an array is called an extent. How many elements are in this array? So for this one and this one, the extent is 5. And the shape of an array is defined as a combination of each rank and the extent of the array in each dimension. So in our case, because we are using only one rank arrays, in other words, arrays that are 1-dimensional, so the shape will be usually the same as an extent. The number of elements will be similar. Thank you. See you in the next video as we continue on the declaration and other aspects of arrays. See you.